This open source robot arm is completely 3D printed and needs only 6 servos, 1 adapter board and 3D printed parts to assemble. If 167 arms are made, the cost for each will be under $100. All of the STL files needed to print the arm are available on the Robot Studio GitHub page, links given in the pinned comment and the description. You can download all the files as a single zip, and this will include all of the GUI and driver files needed to drive the servos. Or you can download the individual STL files from the STL files folder. If we can crowdfund the purchase of the parts for 167 arms, the cost for each arm will be under $100. This is how it begins. Just putting down a raft. It'll take about 13 hours. Wonderful. Looks really clean. No obvious mistakes at this point. Very thoroughly dried filament, so it shouldn't have warped either. With the new techniques we've learned for making holes that don't need supports, I've gone back up to a much bigger thickness, and I've also increased how much the servo is being retained by the print itself. Because the screws which come with the servos are quite short. That's these ones. I've ordered up some longer ones, but one of the constraints is to only use the bits which come with the servos. Somewhat self-imposed. I suspect for the stronger versions we'll have to step up. But for now, we are going to check if this still peels very easily, which I would hope so. This is my favourite carbon fibre. You can hear it popping off already, just as I flex the base. And what I love about this material is that it is incredibly strong. It is incredibly strong between the bonds of the layers particularly. But yet it's really easy to peel if you set it up properly. So let's find out. As always, I recommend wearing gloves, something which is tight-fitting and good for handling tools with your main hand, I guess you'd say, the hand we use to hold your tools, and something nice and chunky to absorb impact. So if you slip, you're not going to cut yourself, you're not going to bruise yourself, because you will be using some sharp tools. So, first question, does this pop off at all? And stop. You can't do it by hand, or you haven't used too much force. Just get yourself one of these. Okay. Now, the pieces themselves, everything has been reprinted apart from the base. I can do it in a single hit. And the big difference is these arm pieces now, which are much, 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 much stronger. But otherwise, not enormously dissimilar. Except for one important detail, they now come in 2 lengths. I did initially try to only have a single arm piece to decrease the part count, but in the end, for structural reasons, I've had to make them different, and so from that point you might as well make the length difference as well. And I think it works out much better, so that is a better way of doing it. Previously, I got rid of a lot of this material so that there were just no supports, but in the end, I don't think that's such an important consideration, because as long as your supports come off like that, who cares? And it also means I've been able to put in all of these fillets and curves again. If it doesn't peel that easily, then you need to check your settings, because otherwise it's going to take longer than necessary. So we should just be able to grab under there. Lovely, there you go. As it happens, that is set to the maximum on my machine. As easy to peel as I can make it, and that's how it comes off. And I've stuck with the same machine for a long time as a result. If you're pushing really hard, do not push towards yourself. Because when it goes, it tends to go quite suddenly. Haven't made this one as strong, but maybe we will. Expecting to do a lot of different iterations of the jaws themselves. Oh yes, so just going back to the arm bar, there is a slight difference to these ones, but there is a whole set of supports to be removed, so we'll see how that comes out. We shall see how that comes out for people on different printers. Scrape it clean, and the only real question is whether or not it can fit a servo. Oh, the answer to that is yes. Very nice. Screws now are really just to retain it. That, I suspect, I can no longer break by hand, so that's a solid start. Excellent. Tolerancing that on each machine really becomes a challenge, so what I will probably end up doing is issuing files that are slightly loose, slightly tight, or bang on, and eventually we'll build up some kind of picture as to what's most helpful to people. Okay, and this one. So this one, in fact, is rather loose in comparison. And that is a feature of the printer and of the orientation. This one, in fact, is probably more accurate because the outline is being generated by the printer exactly, whereas with this one, it's going to be constrained by the layer thickness, and I'm printing in 0.4 to make it as fast as possible. So that's possibly a little bit lucky that's worked out at all. And I assume this fits across here just fine. Very good. Okay. So new design of moving jaw. Very nice. excellent. Very nice. This one again, virtually no support needed for all of that. As long as you've set your support generator to ignore slopes over 45. I might change the slopes of these to 44.9 so you can just set it to exactly 45. At the moment I'm setting it to 40, which have a slight impact on how well these are defined. And also the side fillets. But really that's coming out nice. Very good. Again, almost all the force is now taken by the structure itself. The screws are just stopping the servo from falling out. Okay, those are our prints. In order to set the arm up, you're going to have to reprogram these servos. Each one needs a different ID number, and you also want to set up the center of the servo horn. There are two kinds of servo horns attached to the servo. Don't lose any of these screws, by the way. The brass shaft at the top where the sticker is the driven side, and it uses a spline, which is a metal shaft with lots of teeth on it, 25 teeth to be exact, and they fit into a corresponding hole with the same number of grooves in the driven servo horn. On the opposite side, there's just a loose pivot. Pretty smooth actually. Glass-filled nylon on aluminium, not a bad bearing. One of the screws in here is a stubby, large screw with a washer built in. That's for retaining this. You don't need to use it. If you do, it's going to make it harder to assemble everything else. So just keep that one to the side until you're ready to go. And then we want to program these. You're going to need an adapter board. You're going to need to connect it to power. Looking at about 6 volts. Is a nice amount to be testing with. The board by itself won't pull anything. There's no LEDs which light up when you turn it on. However, when you connect it to USB, I think one does come on, so let's find out. There we go. So with USB, LED comes on. You should hear the computer connect to it. Before you can do that, follow the instructions and install the drivers. And then you'll have a GUI pop up, like so. I would do a screen capture, but I can't get it to work with a normal Xbox screen capture. I can't get it to work. That's what you're going to see. Servo plugs in. You can see the corners have been knocked off. So servo plugs in this way. And then on the side where there are 3 pins, that's where the cable is. You plug that in as well. So let's have a closer look at the connections to the adapter. Power goes on the same side as the servo connections. It's important that this is set to 5 volts. USB plugs in there. you plug everything as I just described. Start the GUI, and the default baud rate, and the baud rate is how often it sends digital bits which make up the serial message, by default is incorrect. This needs to go to 1,000,000. You hit open, you get no feedback at all. When you search for servo list, the servo should pop up. If it doesn't, the things to check are to make sure that everything is plugged in, to make sure that the board has got power, you've turned your power supply on, and that the switch is set to 5 volts. And then also try restarting the GUI. Now, and that's just all you can do. And just keep trying it until it works. But the default ID for all of the servos is 1. So if we now connect a second servo and we try and search, it's going to get confused. So what we're going to do is we're going to set this one to 6. And the way you do that is you go to the second tab, which is programming, go to the second tab, which is programming, select the servo you're interested in, and it will automatically load all of the information. And you can see up here, this is ID 1. We're going to set that to 6 and hit save. And now when we look back over here, we can see that the ID has changed. If we now plug in another servo, so we now have 2 servos daisy chained together. When you hit search, you're going to see a 1 and a 6. Servo 1, and you'll see the ID is 1 again. Now we're going to change this to 5. Parameter saved successfully, and now we have 5 and 6 over here. And if you keep doing that, eventually you will end up back at 1 again. And the last one. One, 2, 3, 4, 5, 6. That corresponds to 1, 2, 3, 4, 5, and 6. And so you just want to write somewhere on there with a sticker or a Tipex or scratch it or something, the number of each one. They used to provide a little sticker for it, but I don't seem to do it anymore. One. And if you want to see, to check how it's going to work, come back here onto the debug tab, select servo 1, not sure you can see that very clearly. You can tune all the parameters in programming. You can change the P gains, the I gains, a lot of things can be changed. And if you select number 2, this one will move instead. And the full range is 4095 to 0. So we're going to set all of them to 2048. And you can do that by doing a sync write. Which will make them all write to the same place. Okay, so now all your servos are labelled and they're all centered. Okay, now that our servos have got the IDs programmed and they've been labelled, not brilliantly easy to see, but you can just about manage it, we're going to set the servo horns up on all of them. All the servos are going to have the servo horns attached the same way. And that is so that the holes are horizontal and vertical. Not an angle like this, like that. As near as you can get it. There are 25 splines. So in the centre position you found, you'll be able to get somewhere reasonably near. Something like that. And the only other thing you need to make sure is that these push all the way down. And that's it. That's how you touch the servo horn. You can then take a screwdriver and one of the screws and just tighten that in there. Repeat that for all of them. So if you take a look, you'll find that there are some screws like that, and those are the ones that go into the metal. There's some screws like that, and these are the ones which secure the servos through the plastic. And there are a few like that, and these are the ones we don't use. They have an extra washer, and they can be used to secure these. You don't need it, the design will hold itself together. Okay, now that you have your peeled prints, 6 servos set up, screws arranged, and you're going to need 5 of these because the rotating jaw at the end is not double supported. All the other joints are supported on both sides of the servo. Number 6 has a tail attached, and you're going to begin not with the base in fact, but with the rotation pitch, because once it's assembled it's a little bit awkward to access. It's very simple. Put on the rotating pivot, press it onto there. You can see when the holes line up down the bottom. So it should just slide down like that. I mean, you just want to tighten it a little. You'll feel that it's become a little bit gripped, and then that way you can line up the other screws without things getting in the way, and then screw it down tight. Oh, the easiest way to do it is with a magnetic screwdriver. If you have a magnetic screwdriver, simply feed it straight down the hole. So once you've got all 4 started, just tighten it down. No, in fact, these large ones use a P1 or a PH1, Phillips or a Posi Drive 1. So that's what you need to use to engage properly. As you're screwing against plastic, don't go mad. You want to do it what's called finger tight. You need to be pushing it together hard. And just by pinching that with your fingers, give it a little nip. Just like that. Check that everything's rotating freely. And then on the bottom, there's only 2 in fact. Just need to line these up. And again, just finger tight. And that secures servo 6 to the rotation. This cable passes back through the hole, and then the servo just pops into the base. And now it's for smaller screws, and these take a pH 0. Again, push the servo in hard, push everything together, and just tighten those down, finger tight. These are a bit pointier, so you can probably just screw them down tight straight away. As long as everything's pushed together firmly, it should all locate exactly in the right place. The bottom can be a little bit more awkward. The way to do these, again, easier with a magnetic screwdriver, or you hold it with your finger, and then you just need to get the tip into the start of the hole. Do enough of a turn that the screw doesn't fall out when you reposition the screwdriver. Try it again. So just hold it like this, press it into the hole, push the servo tight against the back, make sure it's square so everything lines up. Screw it down. Same again on the other side. And again, just make sure it's square. And the servo's pressed back firmly, and it should just locate straight into that hole. Okay. So you need to make sure your wires are not tangled up. And that is the first joint assembled. So next we're going to secure servo 5 to the rotation pitch piece. Make sure the wires aren't tangled. And that has to push down nice and tight. Make sure that this corner here is fully inserted all the way in, and there should be very little clearance between the back of that and the top of the print. Okay, push it in firmly. 1, 2, 3, and 4. And now we have 2 pieces and 2 servos. To complete the second joint, which is the pitch, take the long arm piece, and you see it has an up and a down, and you want the point of the base and the opening pointing the same way, because the next servo is going to connect there. Take another passive spool, and you'll see there are some grooves here which will clear the screw heads. This goes on with a little bit of a struggle, because once it's on, it won't fall off by itself, is the idea. Just makes life easier. And you want this straight up before you start screwing it into place. Make sure none of your cables have got pinched. And in fact, looking at that, yes, that's the right way around. The wires can be swapped over, and now would be the time to do it, I guess, but that's the correct way. You need as much length on this one as possible, because it has to get all the way up to here. That one will go there. So this wire has to be there, and that wire has to be there. And if you've linked them all up as indicated, that will happen automatically. So first of all, we line up our driven side. So make sure the holes are lined up, and then drop in one of the larger screws. should feel that start to engage, and repeat for the other holes. Should go in with a nice hard shove and a twist. Just finger tight, nip them up. Okay, so our other servo, make sure the wires are untwisted as much as possible. That pushes down into there, and then it's 4 of the smaller screws. If you do have any tiny bits of support left in there, just hook them out with a screwdriver. You want to make sure that this area is clear so that the head of the screw doesn't split the print as it clamps down. Make sure the servo is firmly pressed in. Okay. Next, we're going to attach the short section of arm. You want the wires to stay on that side, so it's the short side where the wires go. That should press in firmly like so, and then take one of the passive horns. And again here, you can see there are grooves in the structure to make that pop on from underneath this time. And the middle action of this is at a right angle. So put that at a right angle and screw it together. Just push it down quite hard. The screws are going to bite into the plastic and then screw into the metal. And that will also help prevent them from falling out from shaking. Oops. Okay, and do this side as well. Just line up the holes. Next, we will attach the wrist pitch to roll. That's the wrist pitch, the roll comes out the front. The wrist pitch to roll. That's the pitch of the wrist and the roll comes out the front. Which means that this servo attaches. Which means that this servo attaches to the back here. And again, you've got these cutouts to make it easier to insert. And then the roll servo goes inside here. So as usual, put on your passive horn. engages like that, and center for the wrist pitch is like this, and then screw it down. Nip up finger tight as always. And then do the other side. Okay. Everything should be moving freely. 2 to go. This one goes in here. Make sure the wires are untwisted. Pops back like that. Doesn't need a passive spool on the back. Not for now anyway. Same procedure as always. Make sure the servo is well engaged and then add some screws. So in fact this one wants to be flush to the top. So take a moment to make sure. Take a moment to make sure that the holes are lined up. Okay, last one. This is the fixed jaw. And the neutral position for that. Depends on the wires as always. Okay, so in order to fit that together, make sure that these surfaces are clear and clean. You have little nodules being produced by your printer. You may have wet filament, but it can affect the quality of the flat surfaces. This is pushed back firmly against here, and it engages into that groove. And that's important to resist the torque, and then it will go all the way down like that. So in fact it goes this way up in order to give the wire as much movement as possible. It just sits on there. And the same procedure as always. 1, 2, 3, and 4. Okay. Now place the servo, making sure it is engaged in this groove back here, and then it clips down and secures, this time with slightly more screws in fact. It's 3 on this side. You see these little completely holes. Maybe nice fit the surface. Just finger tight. You don't want to pull it. Don't want to twist it so hard that you pull the screw all the way through. Okay, so now we have half a jaw, rotation, pitch, elbow, wrist pitch and wrist roll. Second to last thing to do is to attach the moving jaw. Passive spool goes on there. Same grooves to allow engagement. Starting position for this jaw is like that. And now the removable jaws are attached. Put one through this corner, one through that corner. And then the last ones to do up are 4 on the other side of the movable jaw. There we go. All right, let's give it some power, see what happens. It's going to move pretty fast. And it's really quite strong already. And strong enough to survive impacting itself, which is important. Much better. Okay, I think that's a pretty decent design. A couple of tweaks to go. I'll do those now and update the STL files. But that can be made in what? Not how long that was. Half an hour?